This will be the last lecture for Environmental Assessment, EREC 240. And today we're going to talk about the Alberta Tier 1 Soil and Groundwater Remediation Guidelines. You can find these guidelines on the Alberta Environment website. The most recently updated is called the 2014 Alberta Tier 1 Soil and Groundwater Remediation Guidelines through the Land, Forestry, and Policy Branch Division. Alberta has a framework for the management of our contaminated sites, and there are three outcomes that the government hopes to achieve through this framework, including pollution prevention, so avoiding impairment of or damage to the environment, human health and safety, and or property. Also, health protection, and this is to take action on contaminated sites that might cause a risk to human health in particular, and then productive use. We want to encourage remediation and return of contaminated sites to a productive use. There are three management options that can be provided through this legislation, and they are the Tier 1, Tier 2, and exposure control guidelines. So, within a given land use, sites might fall into a range of sensitivities because they might have different receptors and different site conditions. So, we have to take into consideration what kind of land use we're going to use when we're looking at these guidelines. So, for example, how you would treat a wetland, a pasture, and an abandoned gas station, for example, would be different because they have different sensitivities and receptors. So, for example, if you were trying to think of a receptor, say that the gas station would have that maybe the other two might not, think about it. Where is it located? It's an urban area. So there will be likely be more people. Well, something like a wetland might have a lot more in terms of a sensitive species. Tier 1 guidelines are generic and were developed to protect sites at the more sensitive end of the range. At Tier 1, exposure pathways that are part of the generic scenario for the applicable land use may not be screened out. And this is always based on the assumption that all exposure pathways and receptors relevant to a particular land use are present. The Tier 2 guidelines allow the consideration of site-specific conditions through the modification of those same Tier 1 guidelines. Now, the generic conditions used to derive the Tier 1 are almost unnecessarily conservative. And so the Tier 2 guidelines will normally be determined by screening out different exposure pathways that maybe are not present on that site. And then they can adjust Tier 1 models and do a more detailed site assessment as it's required. So these types of sites may have additional assessment, monitoring, and regulatory requirements depending on what exactly you adjusted for that site. So exposure control or risk management is used for sites that require restrictions to the typical activities that might be considered under that given land use or require maybe some ongoing risk management. So the whole point of the exposure control or risk management is to eliminate or mitigate any of those exposure routes to receptors and ensure that short-term contaminant levels exceeding a guideline do not cause an unacceptable risk to the land. So examples would be I have one in the next slide, actually, so we'll go there. An example of exposure control is shown here this is from Pinal Creek, Arizona. Now, this water, as shown on the left-hand side for 1993, was contaminated with metals, and it also had a very low pH in the water. So the source of the contamination was actually an acidic plume of contaminated groundwater from acid mine drainage. But because of the way it interacts with the metals, it leads to a lower pH, and also it is acidic. So the findings are that they had been pumping water to out of this channel here into a wastewater treatment facility, and they found that the stream channel was beginning to change. And so because of that, they were able to speed up the natural attenuation of metals. So the remediation plan in this example required a period to achieve the guideline. They wanted it to naturally be cleaned up. It required a period of time to do so. And you can see that now in 1997, Pinal Creek in Arizona is looking a lot healthier. Another example of exposure control or risk management would be like if you had a spill on site, but the site is still operating. So you put in engineering controls as shown here. These are like booms until you can actually remediate what is going on. There are two key acts that form the basis, the legislative basis of Alberta environment policies on the management of contaminated soil and groundwater, and those are the Environmental Protection and Enhancement Act, as well as the Water Act. The EPEA is really important, and that's the Environmental Protection and Enhancement Act. It's really important when considering the Alberta Tier 1 guidelines because it prohibits the release of substances that will cause an adverse effect. It authorizes the director or inspector to issue remediation certificates, and it includes requirements for the conservation and reclamation of specific or specified lands. The Water Act is important when considering the Alberta Tier 1 guidelines as well, because water is a public resource and it's owned and regulated by our government. And these regulatory requirements relate to the management of our water supplies and water quality that are found within the Water Act. So the key elements of Alberta's framework for the management of contaminated sites include source control, contamination, delineation, and then managing those contaminants. There are so many different sources of contamination. For example, you could have a leaking pipeline, a leaking storage tank, contaminated soil, and groundwater may be a source of contamination to actually other areas as well. Because if the contaminants are mobile, then they will spread. So failure to control sources may increase costs due to the spread. Now, if a source removal is not feasible, it has to be controlled and treated. We do need to keep in mind that there are times that we may have substances that are actually naturally elevated. An example of that in our mixed grassland region is boron. So high levels can cause toxicity that will reduce crop yield and kill plants, but many mixed grass plants can actually tolerate a high amount of boron. So high levels of boron can also be an okay thing. And this map, it switched. This map here is showing where the boron is really, really high in our area, in the mixed grassland area here. So when we're looking at delineating the extent of our contaminants, we need to show all applicable exposure pathways and provide information on where we're going to remediate, and this is contaminant management. Now we can get into how we actually use the Tier 1 and Tier 2 guidelines and exposure control. So what happens is originally you will look at the Tier 1 assessment. You'll think, this is what I'm going to go with. You'll evaluate to make sure that it is the right thing to do. And then you'll make a decision. And maybe you're going to make a decision that, hey, I need to move on to my Tier 2 guidelines because this one here is considering, contaminated groundwater, for example. And maybe your site actually doesn't have that. So then you can move to the Tier 2. If not, then you remediate to Tier 1 guidelines, and then so on from there. So what does that exactly mean? Well, it just means that each guideline, Tier 1 or Tier 2, will tell you exactly what threshold of a certain metal, salt, or whatever it is that's allowable on that site. So it all starts with a preliminary site characterization. The level of detail is at the discretion of the proponent, but providing additional information may be used to help you develop any of those Tier 2 guidelines. Minimum requirements for the Tier 1 assessment include knowing the site description and land use. Land use is the most important thing, and we're going to go through all of the different land uses. Your proximity of the site to surface water and drinking water, actual and potential uses of groundwater, and then who are your human receptors and ecological receptors. We'll also look at physical conditions, so like our soil particle size, properties of superficial materials, depth to groundwater, presence and types of buildings and other structures. And then we want to look at the contaminant characteristics and their distributions, both horizontally and vertically. So let's talk about how you would determine your generic land use category of a site. So this is determined by looking at the site description and the land use conditions in the past, present, and future. And so your generic land use categories that you have include the natural areas, agriculture, residential/parkland, commercial, and industrial. So if you have more than one, assign the site to the most sensitive applicable category. Now, there are also groundwater and surface water conditions or categories that are assigned for your Tier 1 guidelines, and these include potable water, surface water that is sustaining an aquatic ecosystem, water used for livestock or wildlife water, and then irrigation. And again, you will assign a land use category, might be natural area or agriculture, and then you might have to assign a water use category. Is this used for irrigation, for example? And again, what if there are several categories your site falls into? So assign the site to the most sensitive applicable category. Examples of factors of greater sensitivity are a greater frequency or intensity of human or ecological exposure beyond typical use of the land or water, and variation in physical site conditions resulting in greater exposure. And let's talk about some of those physical site conditions and what might be the most important. Soil particle size is important in your site characterization, and this might be one of the most important things. The dominant soil type governs which fate and transport via the various transport and exposure pathways that any contamination will follow. For example, a continuous layer of coarse-grained soil beneath the water table will often help you govern the groundwater flow in the saturated zone. So even if you've got a thickness that is small in relation to the total thickness of the saturated fine-grained soils, it's still going to govern how the groundwater is flowing. So at the same time, a thin layer of, say, fine-grained soil in the unsaturated zone may be a more significant control on the migration of vapors than a thicker layer of coarse-grained soil. In this kind of exercise, use your professional judgment to help you establish the dominant soil type. And just keep in mind that soils in reality are a mixture of particles, particle sizes, and they have a lot of different ranges. The dominant soil type, again, will govern that, governs which fate and transport via the various transport and exposure pathways. Small particles will always pack together most closely, leaving many small pores. And I'm going to press play. Hopefully you guys see it on your end, and you can see that large particles pack together more loosely, leaving few but large pores. So you can see how long it takes for the water to filter through these different materials. What are some of the conditions that might trigger a Tier 2 guideline? So some of those triggers include a source of volatile contaminants present within 30 meters of a building foundation, unique building features, something like an earthen floor or a really low air exchange rate, sensitive receptors not accounted for in the generic Tier 1 land use. For example, the Ord's kangaroo rat is sensitive and often not considered, and groundwater flow to stagnant water bodies. Moving on from that, we also will look for contamination present within 10 meters of a surface water body, very coarse textured materials, contamination in fractured bedrock, contaminant source length parallel to groundwater flow greater than 10 meters, and organic soils. So, in review,